Hello world, this is Coder's Cove and welcome to a new video. Last time we talked about the dark and evil sides of AI, and in this video we will explore one of its facets. Well, we can't synthesize napalm due to a lack of chemicals and the fact that this is a software engineering channel and not a chemical one. We will be writing a reverse shell in Python. We will actually be writing two scripts on two different operating systems. This can either be done on different machines or by installing a virtual machine on your own OS, such as VirtualBox or VMware. I will be using a Kali Linux VM for this tutorial, where the attack script will be situated. The main Windows OS will be designated victim in this case. In order to use this script's attack successfully, you should have your FTP and TCP connections allowed, which by default are disabled by Windows. Well, at least the modern Windows 10 OS will disable them. So you will have to enable them yourselves. Anyways, once that is taken care of, you should also install Python, and we can pop to our Windows and write our own TCP client script. So, okay, here we are in our Python scripts folder. I will create a file called tcpclient.py. Since I might end up reusing the script on a Linux system, I'll start by writing the following. This thing, usr/bin/python3. This is called a shebang line, and it specifies the interpreter to be used for executing the script. In this case, it indicates that the script should be run using Python 3. I mean, this works for Linux systems and will have no impact whatsoever on the Windows system. More specifically, I wouldn't have to invoke Python as a command. I could just execute the command as any other binary executable, instead of running Python as a command and then the name of the file. It shortens the work and it's fairly cute. Also, we will be using the Python socket module, which provides low-level network communication capabilities, and to do that we import socket. As well as socket, we will also need to spawn new processes and connect to their input, output or error pipes to obtain their return codes. And to do that, we will import the subprocess module. Now let's define some variables. In order to connect and establish a connection without it failing and continuing to work, we will need to have the TCP port captured as a variable, or, well, used in general in the function we invoke, but keeping variables is much easier and more concise. I talked about that you should enable the FTP process because we will be using port 21, which is commonly used with file transfers. Aside from that, we will also need the IP address. Now, for you can simply go to your terminal, type ipconfig, press enter, get everything. And from there you would get your own IP address. I already know mine. 68.0.39. Now after that, we will have the size of the buffer, which is used for receiving data from the server, and we will set it to 30 bytes in this case. This is just for informational purposes. Okay. Now we can get down to creating the socket. So we will call the variable s because we will be using it quite a lot. We don't want to repeat ourselves too much. So this is socket.socket. And we will be using the IPv4 address family, which is this here, instead of IPv6, and the TCP protocol. To do that, we just type socket.af_inet. That's for the IPv4 thing. If we wanted the IPv6 address, that'd be af_inet6, and socket.sock_stream. That's all we need for now. If this works, we'll do this. Now we can connect to the ports. This function actually accepts as an argument something called a tuple, which is basically an array in regular parentheses instead of the squared ones. It's a bit different than an array in a sense that it cannot be directly mutated, so it's more like a const from JavaScript in that sort of way. What we will be doing is adding the IP address first and the port second, and write another print function here. Socket to port. So at this point we should have the infinite while loop, and this one is used for receiving, parsing commands and returning the output of said commands. So in this case, let's have the command as a variable, and it'll be sent to socket.receive. Everything from 0 to the buff size, which is 30 bytes as we have already said, and we will decode it using the UTF-8. Now if this will give us the text that we had sent, and if the command is exit, we will simply close the socket and break out of the infinite loop. Otherwise, we will have to run the command as a sub-process on this machine, which will give us the output to be sent back to the server or the other machine which is running the server script, if that makes any sense. But since we have the lowercase command already used, I'll do it in all caps. Subprocess.run command from shell. Now we have to connect standard out, subprocess.pipe, and also the standard error, which we will actually be connecting to the standard out, because we really don't want to be bothered with errors right now. Once we have all that, we can simply send the command or the results of said command back to the server. All in all, this is basically it for the client script, or the Windows victim script as it will be. So now let's pop on over to our Linux machine and write the server script there. So here we are at Kali, this is how it looks, and it's the hackerman's favorite tool. Why? Because we can write exploits. The most useful and by far the most used app on a Kali Linux machine or operating system is by far the terminal, or this thing here. I will now create a directory here and a file for the TCP server. But before we do anything else or opening it, let's just list it, and as we can see here, we only have read and write permissions as the administrator or the root user, while as the regular user or anyone in the group we only have read permissions. To change that, we'll write this command chmod +x and then the name of the file. So now if we list, we also have the execute permissions here. Now let us, oh yeah, and the file changed color, indicating it can be executed. Now let's open it up and start writing our script again. So once again, I'll add this shebang line and we'll import socket as it is, well, the module we've been using so far. Let's simply configure everything as we did from the previous script, though in this case our IP address will be different. In this situation, we'll be using the loopback IP address, and in this case it'll be 0, oops, let me just, right, it'll be 0.0.0.0, and the buffer size will be a bit larger, since some outputs from the commands can get quite verbose and tedious to look at, but 2 to the power of 16 or like 65,000 bytes should do the trick. Let's again write our informations here, or print to the console, and instantiate the socket. Again, we will be using socket.af_inet for the IP version 4 and socket.sockstream. Now, to fix one of the pesky problems that regularly happen, we will set a socket option, and this will be the option to simply re-allow us to execute this command again and not get an error that the address is in use, because that happens constantly, especially if we accidentally terminate our like terminal command or the script that has been running with Control-C, which is one of the regular ways to stop or halt any execution, and that happens quite a lot. From the server script, there is one difference here, and that is that we will bind TCP_IP. That is that we will bind our socket to this here address, the loop back, as it will, if you will, as it's called, and that'll allow us to listen to any and every, what is it, traffic on the system or network. A TCP port. Okay. Socket is being bound to port. Now we will simply listen. And this one here means that we'll only be listening for one singular connection and nothing else. You could have multiple connections to the same system, but in this case, I mean, we can change this to like 23,548, but let's keep it simple since the TCP client script is also extremely simple, and keep adding these informations for the purposes of debugging. Oops. No. Now, once we have that, we will have to accept the connection incoming, and we will get a new socket, which will be saved in the variable C, or actually I'll call it connection, and address. Accept. Now we'll add some more information. Now we'll also have a while loop here as well. Command will be an input command, and you can put something in front of it. It'll basically freeze up the whole program, and it will allow user to type something by themselves, which will be saved in this here variable, and it'll be reusable. So we will put this in front so the user knows that they're typing a command, and we will encode it in UTF-8 so that we would decode it on the client script using the same format. Again, if the command is exit, we will send the exit command and encode it once again. Oops. We will also close the client socket connection and close the regular socket connection, and then we'll be breaking out of here. In other case, we will send the command and we will print to the screen what we have received. RECV. It will allow us around, again, like 65,000 something, I believe, bytes. So that'll be plenty to simply show everything on the screen that we need. Save this and check everything for syntax errors or something. Okay, right, no, I think it all looks good. Now for the last part we will be testing our scripts. Okay, now let's test this bad boy out. So here I'm going to run the TCP server.py command. Everything looks well, and on my Windows I'm going to run the client script and as we can see we already have the input here, and we can start typing commands. Let's just do help, and we get everything here, all the commands. These are from Windows, by the way. So if I type ls, for example, which is a Linux command, I should get an error, and I do. Also for clear, which clears the terminal screen. But if I type, for example, dir, which is a Windows command, it lists files in the directory, I will get all of this. Also, I can, well, I don't know, just write another command like who am I, just to check who I am. Okay, and now we'll exit, and this thing here, I'll just drag it on the screen, has exited on exit command. I don't know what's happening here, but okay. Turns out the server isn't as well set up as I thought it would be. But if I type who am I here again, for example, have this one here, I get a different name indicating that we indeed did have a connection to a different machine. We did indeed list the files and directories of the other machine, and I'll prove it by doing ls here, where we only have one file. So, yay, it's worked. So far so good. Anyways, that concludes the video. Thank you for watching. Goodbye world, and have a nice day.